I'm Rathore from Kyungpook National University. Today I'm going to present my paper in IEEE sensors. My topic is IoT-based medical emergency management using Hadoop ecosystem. As we know that IoT is the connection of various devices, things, or sensors. We are going to use these sensors for the medical emergency system, like a person who are doing jogging or riding cycles or going upstairs or downstairs, and his heartbeat is going to fall or going to cross the threshold value, then he should be announced at the real time so that he can take any precautionary measures or any emergency action can be taken. Or if anyone have the heart attack, then any emergency action should be performed, ambulance should be come, or doctor should be consulted, or if any accident happens, then police should be informed in these things. We are doing all of this by using the Hadoop ecosystem. That is the system that is using the distributed file system, and the data. We are using the Hadoop ecosystem for the data analysis. Why we are using? Because it has the distributed file systems and the data is stored in chunks. And from the same data, the parallel processing is performed on each chunks, and we got the results efficiently. These are the contents of the presentation. First, the introduction, in which that IoT and the sensors produce large volume of data. We named it as big data, and we discuss about something related to big data and what are the key challenges, why we are going to develop this system. And the proposed system, in which we discuss the sensor deployment scenario and data generation, and the proposed architecture, how we analyze the data, and few data analysis, and finally the evaluation and conclusion. As we know that the citizen health is important, not only for the citizen, but also for the nation, because a nation cannot be developed with unhealthy peoples. Therefore, the continuous monitoring of the peoples or for the citizen is important. And we are living in a digital era. So we can analyze, we can monitor the person's health in a real time, means continuously. These days, the body area network, that is WBAN, is used for the monitoring of the person's health or for any patient health. But it's in limited scope. Not huge amount of people are using this body area network. When we discuss in body area network, there are various sensors are attached with the human body, and they are calculating, they are measuring the various medical measurements of the person, of the patient, like temperature, heartbeat, and his activity might be activity measures. But when we think about the whole city, means the people living in the city, all the people living in the city, and various sensors are attached in each person of the living in the city, then you can imagine how much data is generated. So this data, which will be in a very large amount, we term that is as big data. And therefore, to process that big data in a very real time is a challenging task. And these devices, why we call it as big data? Because it is of huge volume. When we discuss as the stored data, the data which is in a huge volume, we call it as a big data. And the data that comes from the sensor, from thousands or millions of sensors, and it is in a very high speed. So to capture that data, to analyze that data, and take a real time action is a key challenge. So the data which is in a very high volume, high velocity, and with various varieties, means structure, unstructured, temperature data, heart data, and it is of heterogeneous form. So to process that data is a challenging task. Therefore, capturing that data, storage of that huge volume of data, managing, searching, sharing, transferring that huge volume of data is challenging. And moreover, the most important is the analysis of that data, and so that we can extract some knowledge from them. Like in our system, we can find out when it's a critical situation for our patient, so that we can perform the real-time emergency actions. Therefore, we need special architectures, techniques, algorithms, analytics, so that we can perform the real-time actions and extract the knowledge. In this paper, we are proposing the system that process that body area networks of sensors measurements in a real time using the Hadoop ecosystem and perform the emergency actions. This is the proposed work. We propose the sensor deployment, how the sensor will be deployed in every person, and how the data will be generated and aggregated, and then the proposed implementation model, how the huge volume of data is processed to perform actions, and some of the analysis are performed, and finally the conclusion is made. We use the tool for Hadoop ecosystem, in which they have their own programming paradigm MapReduce to analyze the data. Basically, Hadoop is used for Hadoop is developed for batch processing system, but now third-party tools are developed that we can use Hadoop for the real-time system. So we are checking that with the Spark tool with the Hadoop, combined with the Hadoop to perform the real-time analysis. And we use the Warwickshire system to replay the traffic, to replay the data set, so that we can check the real-time performance of this system. This is the sensor deployment scenario, in which that each person have various type of sensors. There might be some activity sensors to detect the activity of the person, where he is riding cycle, or he is jogging, or he's upstairs or going upstairs, downstairs, these things. And there is one yellow that you can see, the yellow sensor. It is the coordinator sensor we are using, so that the energy can be saved. Because if every sensor is sending the data, then every sensor will consume energy. So every medical sensor will send the data to the coordinator sensor, and coordinator sensor is the main sensor who will aggregate the data and send it to the over the internet. And that we have three type of sensors are attached to every human. That is the coordinator sensor, that activity sensors to detect the activity, and the medical sensors that might be heart sensor, heart measuring sensor, or temperature, or diabetes, or blood pressure. And the coordinator will aggregate the data in such form that it will add the header, which include the user ID and the sensor's ID and the coordinator ID, and plus the activity sensor and other various type of medical sensor of proper sequence. It's not necessary that every person has activity sensor, or every person have different type of sensor. According to this type of sensor, the aggregation will be performed. This is the proposed architecture, in which there is primary medical PMD that can be, means sensor cannot directly send the data over the internet, because it doesn't have that much range. So we use the PMD, primary medical device, that might be a cell phone, or might be a access point. So the data that coordinated sensor will send the data to the PMD, who is connected with the internet. So it sends the data to the main system. We called it as intelligent building. where the analysis are performed. First, the collection data will be collected, and you know that the sensors have a lot of extra data, metadata, and these things. And for real-time processing, we don't need to process that data. So we filter that data, and we convert that data into a sequence file so that it can be processed by Hadoop ecosystem. And then Hadoop is used that have the different HDFS distributed file system where the data is divided into chunks and parallel processing are performed using MapReduce. And finally, after it, might be some medical expert system or some threshold-based technique. As a simplicity, we use the threshold-based technique where when the threshold is increased, it generates alarm to the user as well as the doctor. And the result can be sent to the doctor or hospital or ambulance according to the scenario. We use the data set we use. This is the description of that data set. We replayed that data set over the system to check the performance. We use Spark as we already described. These are the analysis results. That diabetes result when this yellow line, when diabetes cross that yellow line, then it generates alarm to the user as well as to the doctor and send the prescription to the user to increase the dose level or other precaution measures. This is the system evaluation we perform with respect to the average processing time and throughput. When we increase the number of sensors, the processing time definitely will increase. But the thing is that we increase the large amount of sensors, but processing time is very, as compared to the sensors, the amount is very less is increased. And for the Hadoop, there is major thing is that when the data set increase, the throughput is also increased as compared to data set. So this is the conclusion. We propose the system in which we use the Hadoop ecosystem to process the medical data for real-time actions.